Kannst du mich hören? Ich habe zwar kein Funkgerät. Wackel mal mit irgendeiner Kamera, wenn du mich hören kannst. Kommt hier was raus? Hier kommt auch kein Ton raus.
And we have two parts this morning that I will explain.
Test. Test, hallo?
Ja, die Punkte, ich
Test, 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 hallo? Jo.
Ja, ich habe auch meine Belletristik hören, Florians Reise durch
Test, Test, Test.
Wo ist er? Ja, cool. Links?
Dann eigentlich mich recht nicht ganz gut und ich freue mich sehr drauf. Und das ist so immer.
Ja, das war, ja genau, das ist aber immer noch die Beispiele.
Ich habe jetzt auch allein das gelesen in Bezug auf mein Ziel. 97.
Ja.
Ich war schon ganze 8.
Ja, okay. So, 10:04, dann fangen wir mal an. Ja. Tschüss. No coffee, no working. Da gibt es einen guten YouTube-Kanal, der sagt das auch, dass ich im Bild bin. So. Und ja, dann guten Morgen. Schön, dass Sie gekommen sind zu dem zweiten Tag der Volla Community Days 2026. Hello, good morning. Thank you very much for coming to the Volla Community Days 2026 here in Remscheid, and all the people that are watching and listening in our YouTube channel. And you are also all welcome to ask your questions in the YouTube chat. So this morning we have interesting workshops. But first of all, I would like to thank you, the Volla team in Remscheid that are prepared the Volla Community Days, all the work that has to be done, and also in particular Mrs. Wurzer. And I also want to thank all the developers. Yesterday we talked about innovations. I give an outlook about what we are planning, and I think it's really amazing. We are so small company, and I'm proud to work with all the developers in different parts of the world, the enthusiasts for the Volla idea and for technology, and it wouldn't be possible to develop and implement the Volla vision without that enthusiasts and brilliant developers. Thank you very much to all of you, and also thank to the community that helps us for beta testing or with contributions to the source code, and also with some ideas and requirements to the software that we have. Today we will learn about the open source projects of Volla. And in the afternoon, we have a workshop about how to develop Volla cloud apps. So you can use the Volla cloud and the Volla cloud service on Volla as an ecosystem for your idea, for your app. This morning, we start with unified attestation. Unified attestation as an open source, trustworthy alternative to Google Play Integrity. And so I welcome Mr. Abdi, one of our senior developers, also one of the brilliant ones who implemented the first, the unified attestation alternative. Behind unified attestation, there is also an informal consortium, industry consortium. For now, we plan to formalize this consortium. There are some interesting European brands that are supporting that unified attestation, like Morina or IOD, and many others that are interested in the consortium, like the UBports Foundation. So, hello, Mr. Abdi. Hopefully you can hear me. And good morning. And the stage is yours.
Hello, good morning, Dr. Verzer, and hello to everyone. And a special thanks to Volla team for preparing the Volla Community Days, and thank you everyone for joining. My name is Irfan Abdi. I'm the senior operating system developer in Volla. And today I'm going to talk about the new project that we have been working in Volla, which is an alternative to Google Play Integrity. This is called Unified Attestation. All right, let's go. Let's start with what is attestation in the beginning. Attestation is a process where a system proves its identity and integrity to another system using cryptographic evidence. So basically, in Android world or any other operating systems, we need somehow to figure out, is our device legit? And in another way, we also need to prove our app is legit. So applications that are important, like banking application and McDonald's application, for instance, needs to work on a trustworthy environment, on a trustworthy device. So in these cases, we are using attestation. For Google Android, we have something called Google Play Integrity. A few years ago, it was something else. It was called Safety Net, but now it's deprecated. No, we only have Play Integrity API. In this Play Integrity, we now that we will fully discuss about it, it is providing some information to application developers using cryptographic hardware-baked keys that are written inside a factory to our mobile devices. This attestation is going to send some information. It's going to tell app developers your device that your application is running on have a blocked bootloader. It's going to prove that your application is installed from legit sources, and some random challenges or nonce to prove that your application and your server backend is talking properly together. And all these responses are coming from Google itself. So what is Google Play Integrity? It is a part of Google Play services, part of a GMS, that this is going to be only available on devices, on Android devices that are shipped with Google Play App Store and Google GMS, the Google Play services. So there is no way to use Google Play Integrity on custom ROMs or Volla devices or any degoogled other degoogled ROMs or frameworks. This Play Integrity is going to verify the app is genuine and unmodified by checking its signatures and origin of installation. It is also going to check the device certifications. And this is all going to be a server-side attestation model signed with Google keys from Google servers. Let's check the architecture of the Google Play Integrity. We have an application, of course, the client side. We have Google Play backend and developer backend. Developer backend is the application server. Yeah, let's talk about it in this diagram. This is coming from official Android website documents. In the middle of the screen, we have an application that is communicating with Integrity API. It's calling Integrity API and says, okay, we want to make a request to our server. Integrity API is calling Google Play Services, which is on the left side. We don't see that. It is all hidden, lives inside the system, inside the stock framework of Android. But anyway, the application calling Integrity API responses with a token. Application sending this token to its own server, the app server sending the token to Play server, Google Play servers, and then the decision comes from the Google itself. Is this token comes from a valid device or not? And at the end, we get a verdict. Verdict is going to evaluate with the app authenticity. Is it play recognized? The device integrity, device meets integrity, some strings like that. You get the licensing, the account status, which is also optional. Is the device have logged into its Google account or not? But this response is going to be a JWT, the JSON Web Token, with the Google private key. It's going to have the application info, the package name, and certificate, some kind of a timestamp, and the verdict. But let's take a step back and see how devices are going to be certified inside an Android environment, inside the Google environment. For example, let's say we are a device manufacturer, for example, a Samsung, and they want to get certification for their own devices. They manufactured a new device, they built a framework for this device, and now it's ready to go into the market. Now, in this case, they are going to submit their builds to Google. They will gather the information of this build, for example, the firmware image, build fingerprint, and some code name of the device, some manufacturing information, and they're going to submit it to Google. Google responds back with a key, with a private and public key that is going to be installed onto the device in the factory. And now, in the step 2, manufacturers are supposed to run some Google tests. This is called the GMS test. They are going to run the CTS, compatibility test suits, the CTS, security tests, and GTS, VTS, BTS. There are a lot of more tests. And after all these tests gets passed, it means that this Android build that this manufacturer is going to install on their devices are meeting all the security that are necessary to have the device get certified inside the Google. So at the end, you get when you see that your device have Play Protect or your device is certified, it means your device build have your manufacturer ran all these tests and passed all of these tests. So yeah, they're going to insert this attestation keys inside the factory to the TEE of the device, which is a trusted execution environment. And all this attestation that we talked about is going to be signed and be centered around this key inside the TEE. This is a key that only Google and your manufacturer knows about. But we got this idea and wanted to implement something open source. We observed other open source project that is going to be alternative for what Google Play services provide. We saw unified push for push notification alternative. We saw unified NLP, which is a network location provider for proximity locations with the GPS. Besides this, we named this project Unified Attestation. This is an alternative for Google Play API. In Unified NLP, for example, we have a solution that is worked modular. So you can install multiple modules as a backend to your phone to get a proximity locations. For example, you install Wi-Fi cell tower backends. You install Wi-Fi backends, which is going to be a map of all the nearby Wi-Fis. You install a cell tower backend, which is a nearby cell towers. We have a Mozilla location services, local GMS backends. This is all modular solutions for unified NLP. Same thing we have in the unified push. This is a decentralized push notification system for replacement of Firebase cloud messaging. Another, the unified push, you must be familiar with, have multiple services that can be installed as a backend. For example, Next is going to be installed inside the Nextcloud, yeah. Or it's going to be a plugin on Nextcloud or self-hosted like not fee. But anyway, we are going to talk about unified attestation. Let's see what challenges that you have to overcome. First of all, we have to ask, of course, the developers to, instead of using the Google Cloud Console and using the Google Flow, you have to use our unified attestation servers. They should implement a system service inside the firmware of the device that we're going to ship, something like Google Play services. I'm going to explain later, doesn't have to be a system service. It's just a service that for the convenience of this, we're going to place it inside the system. This service is going to be also a federated, something like the other open source solutions, unlike Google Play server, for more trustworthy purposes. We also must make sure our devices that are going to be inside the unified attestation also pass the Google tests. We are going to be in the same level as Google for checking the sanity tests and security stuff for the devices. So we have to use trusted laboratories to run these tests on devices. For example, Google is using Google MADA third-party laboratories to run these tests on devices. We will do the same thing here. And yeah, here's a diagram of how unified attestation is going to work. We try to make it exactly similar as much as possible with the Google. So first of all, developers be familiar and also easier to implement. The only difference is going to be that I will explain later at the demo is going to be the backend selection for the federated stuff. This is the application side. Mostly everything is same as Google. Here's the service side, system service, doesn't have to be a system. This is exactly, again, same as Google Play. What happens in the Google Play integrity? We are using the device keymaster. Keymaster is a service inside the device framework that has access to the key that we write in the factory, the TEE key. API that application is communicating with connects to the service connects to the keymaster, and that is going to be connected to the server, the backend. Here's what's going to happen for the OEM side. We have two things that we have two scenarios that could happen. First is the OEM already have a key installed on their devices. For example, it's a Google device, so the key is already installed, or they can generate new keys from our unified attestation backends, and those can be embedded inside the device as well. So we covered both of these scenarios. And this is the federated approach that I'm going to demo it today. But for the quick talk for this slide, I'm just going to say our unified attestation servers can be worked separately with each other. For example, you can submit your device to one server, and this server is going to have also some application inside it. So these applications are going to work with these devices. Also, you can connect another server, which is only applications, doesn't have any devices submitted to it. And also these applications is going to work on device X. So this is a federated approach. For example, look at backend server 2 as something like F-Droid. F-Droid is not going to manufacture devices, but it's going to be only application only. Backend server A1 can be Volla devices. Volla have some applications that wants to have attestation and also manufactures devices. If F-Droid accepts, adds Volla as a trusted backend, all F-Droid application is going to be trusted on Volla as well. Okay, here's a scary big diagram. We can skip it. API. API of the unified attestation is very, very simple. Unlike Google, it is just taking device attestation cert, certificate chain, some device metadata. The metadata is also optional. It is going to just help server to find the device. Everything we need is inside the certificate chain. And on the backend side for the application server, it is as simple as a token and a project ID. Okay, here is we also had some other open source projects for doing similar things as attestation, open source solutions for Google attestation, but they're not so complete. Here's a bullet point of differences between unified attestation and Graphene OS, Auditor app, and Warden Supreme. Let's talk about it. The differences for Graphene OS and also the Warden is basically there is no CTS tests for this solution. Where the attestation checks have not been verified with any laboratories like Google. There is no CTS, GMS tests running on this device, running on devices to make sure the devices is going to be submitted into these servers are totally valid and passing everything. There is no actual OEM attestation. For example, for Warden, this is only a library installed on the server side and library inside their applications. Then there is no perspective for OEM and device manufacturers to submit new devices. There is no new key generations to put it inside device in the factory, stuff like that. There is also none of these solutions have federated or enterprise trust models. So it's not designed for exact replacement for Google Play integrity for banking application or commercial application ecosystems. And here is some screenshot of the backend logs, for example, how this certificate chains is interpreted inside the backend that we are going to show later. Here is the screenshot of the unified attestation admin portal. You can create users, of course, and for OEMs to add new devices, register new devices, or for application developers to add new apps to this backend. You can generate keys as we speak, and the backend ID and public key of its own backend for doing the federation stuff. On top of the federation, we also have something else called attestation authorities. For example, some of devices, as you mentioned, already have the Google key embedded in them, but we install the custom ROM, for example, into these devices, and we cannot remove the Google key and use another key. So we can add Google attestation authority to our backend. So if you submit your new device, and if your device already have Google key, our backend is going to recognize it as a trusted root certificate, and all this attestation is going to be approved on these servers. We can do the same thing. If, for example, another day, Graphene OS bring up a new attestation authority, our backend can also support it. And federation management, that is for between unified attestation server. I'm going to explore it in the demo today. Here is the OEM portal for adding new devices. You need to, of course, select your attestation authority. What is this key that is installed on your phone? Is it coming from Google or UA. You need to enter your serial keys, and at the end, you enter your build configuration, build policies, your build fingerprint, OS version, OS patch level, and some keys, some ABB variety keys to make sure. This is going to be checked later on to make sure your device have a locked bootloader and it's running exactly these signed builds. These are the public signed keys for your partitions of your device. And yeah, this is just a scroll down of the same page. And yeah, in this slide, you can see the verdict that is coming from attestation servers to some application server. My example application server got a verdict from some untrusted device. You can see the project ID, which is the package name of my application, and the reason why this device is not certified is a build policy mismatch. This is not a trusted device. And you can see the build policies or build configuration of this device that tried to get access to my application. Here is the application portal for app developers. This is very simple. All you need to do is enter your app name. This is optional. Your package ID or package name, it's going to be the project ID, and your signing key, SHA-256 of your signing keys. And this is in the left side, this is an example application that is communicating with only unified attestation and its own app server. On the right side, you can see the unified attestation service. We can enter multiple backends to one device, and application is going to choose what is the best backend to use. We also have reports on the portal to see which devices got trusted, which devices got rejected, things like that. Same thing for applications, same thing for OEMs. And of course, we need to do more on unified attestation. We have to make better documents. We need to implement the RKP server for UAttest. For now, the RKP device is not working properly. And we can also validate the originator of installed packages. So in summary, this is a new vendor-independent attestation framework to verify app integrity and device integrity without using Google Play services. App integrity is used, it's checked by using digital signatures or checksum. Device integrity, like detecting the root or emulator or unofficial devices, all coming from the trusted environment of the device. This signed attestation is using the public and private keys that are embedded in the device, exactly like Google model. Server-side validation provides secure checks. Everything is a JWT, same as Google, with nonce and timestamps. And also the key for unified attestation, then why the name is unified, is because this doesn't have to be only on Android. It can be installed on Ubuntu Touch or other mobile OSs. It is not limited to Android. This is a fully open source implementation. Here is some resources, and here's the GitHub and website of the unified attestation. Okay, let's do some demo. If you excuse me. I'm going to connect my device. This is Evolve 122. Actually, let me show the portals first. Here we have unified attestation. for Volla, let me open Volla account here. I can see the Volla devices going to 623, Linux 22. For example, on Volla Phone 22, we have a build. Here is our build that I'm going to demo today. All the keys. The OS is Android 16. Patch level is very recent. Here's the trust anchors. The authority is coming from Google. Here's the serial number of the keys that are installed inside this device. This is coming from Google because this device already had Google Key installed. Here is some reports that I got when I was testing. And yeah, here this is our portal. We are on backend A, for example. Let me show you. Let me show the test app. This is also a application portal for app developers. We are going to demo in a unified attestation example app. Here's the signing, signature, certificate, and the app name. Okay, let's start. First, let's check the unified attestation service. Here you can see the backends that was installed into this device. Let's check the health. The status of the backend is okay. Let's check this. Sanity is okay. This backend recognizes this device. Now, if you want to check it out with the example application, we are running the attestation, sending a hash request. The selected backend finds the best backend to work, and token received from server, and the verdict is this device is trusted. Let's check the Docker side of this example app to see what is going on exactly. As you can see, here is the verdict that is trusted, and the device integrity, is this device bootloader locked? True. Is this the verified boot is running on this device? Yes. And all the stuff. Now I want to use exactly the same device, but with the unlocked bootloader to see what is going to happen. I'm disconnecting it. I'm connecting another Volla Phone 22, exactly the same build, but unverified, because this device have an unlocked bootloader. Let's check again. Sanity is okay. UA example, running attestation. As you can see, the build policy mismatch. Let's check the Docker of the application server. Here, this device locked. No, this device is not locked. False. The verified boot key is 0. This means this is why we got this reason. This is some kind of like the device meets integrity of Google, but much simpler. Is it trusted? False. It's not trusted. Let's do another device, another more recent device. This is Volla Phone Cointus. But for this device, we are, I think this is also a unlocked bootloader device. As you can see, we again got build policy mismatch. This is not trusted. But let's also test federation real quick. I'm going to demo on another device with a full Google device. This is another device that I have. Okay. It has a Google Play Store installed in it. I logged in with my own account. As you can see here, oops. This device is certified with Play Protect and meets the Play integrity. And when we want to show the attestation, unified attestation, as I said before, this doesn't have to be a system service. It can be a user. It is a user service that is embedded into the system. We don't have the keys of this device, of course. So this is not a platform application. This is a user app. And yeah, let me tell you something. In this device, we are going to check it out on a backend of C. So this is our backend, our device. This is the submitted device on another backend, which doesn't have any application inside. There is no application inside the backend C. We are going to connect the federation of both backends, backend A and backend C. But let's check. First, let's check the unified attestation example app. As you can see, application server is trying to communicate with its own backend, which was backend A, but device was submitted on backend C. So we got this error, invalid token. Backend A doesn't recognize backend C devices. So we are going to the admin portal. Here, we are going to add a backend URL of C. Server C. Now all the applications that are submitted inside this backend will work on devices on backend C. Let's try the attestation again. We got the verdict. This device is trusted. Very simple. Let's see the response on the server of the same application. We got the backend. We got the verdict, all the verified boot key and stuff like that. This was on a totally Google device. There is no de-Googled stuff on this device. So I just wanted to tell you the unified attestation can work on side by side with the Google Play integrity on Google devices as well. Now, okay. Now let's try something else. In this demo, I also wanted to yeah, let's yeah, 1 second. Let's submit a device and see how this is going to work. I'm connecting my Vodafone 22 again. Here's the unified attestation service. I'm going to add a new device to a new backend. So we have a backend B, here is called. Backend B is totally new. It doesn't have any OEM account in it. So we are going to create a new Volla account here. It is a OEM. User is created. Volla. As you can see, there is no devices in this backend, and we are going to use this as a backend URL. Adding. Let's check it. Device metadata. It means device is missing in this portal. Let's disable the backend A for now, and we are submitting our device. If you are a developer, if you are a OEM, you have access to the portal, so you can generate a API key. Now we're getting an API key for easy device adding. Writing the API key here and pressing submit. Okay, yeah, we got the root certificate error. And this backend does not recognize Google devices. So we have to add Google Authority. We're going back to the admin page again. As you can see, Authority is missing Google. So we're going to add Google URL. Yeah. Let me copy paste it real quick. We're adding the Google Authority to our backend B. Refresh. We got the backend cached all the Google keys. So now if I try to submit again, I shouldn't get any errors. Yeah, submit. Submitting to backend and submit successful. And yeah, we have a delay. I pressed it twice. Submit was successful. Now we have our device inside the backend B. Mimomite, Vodafone 22 class with a trusted anchor and build. Here's again the build policy. If we try to call example app, it's going to fail because at this stage the B backend doesn't recognize B as a valid. So we have to again add the B to the federated ones. B. Now let me run again. It is trusted now. As simple as this. One more thing I wanted to demo is how we can integrate an already application that is working with Google Play and integrate it to unified attestation. When I was looking into the web, I found this sample. This is a Play Integrity API sample, and someone created an application and also a server for demoing how to connect your applications to Play Integrity. You have to have a Google Play console and everything to work with the Play Integrity APIs, but we're not going to exactly test that. We are only going to see how what it takes to bring up a unified attestation to already Play Integrity app. For example, we have banking application that is works perfectly fine with Google Play API. We want to add UA to it. Let's check. This is just, here's the diff that I did at last night to added the UA to this application. This is just some UI sites. The main difference is this. We're going through it. And for the server side, also these edits. As you can see, this is a very small edit, probably 50 line of the code. And inside the integrity manager, it's less than 100 code. And if we want to compare the implementation of the Google integrity and UA integrity side by side, you can see how simple it is. It is done exactly as much as possible, same as Google. We have SDK for both Android, and for server side, we have SDK for Python and Node.js for JavaScript. But for the Kotlin for Android side, in the right side, you can see integrity. In the left side, I don't know if it's possible to see. Is it too small or no? But I will push the code later. Here is the unified attestation. The only extra step is for selecting the backend, for finding the best possible trusted backend to run your to send it to your app server to run and use this backend. This is the only extra step for unified attestation. But besides that, everything else is similar. You're generating a nonce, exactly generating the nodes inside the Google side as well, sending the nodes to your server, sending the nodes to your server after getting a token from Google, after getting a token from UA services. And all the endpoints is similar together. I will also show you the server-side changes. For the server side, we are using our own Python library. First one is select backend. This is the new thing, but the verification part is exactly similar. We have a decode token. After decoding, you get the verdict from our backend. Now let's see this on real life. This is the play integrity sample. Yeah, this is exactly this application. Failed to connect. Oh yeah, I'm not running the server. Let me open the server real quick. Start. Connection true. Generating nonce. We are using exactly the same way that is generating nonce for Google, and we are pushing the same nonce for UA. And here is the verdict that comes from our backend. This device is verified. Verdict is trusted. And all it takes is less than 200 codes, which is mostly similar to Google as well anyway. And thank you so much for listening. This was all mostly the technical parts, but if you have any questions, I'm glad to answer. Thanks for listening.
Yeah, thank you very much. And now I'm looking for questions in the room. Here, over there.
Thank you for the presentation first. And my question is about what can an app developer expect from the hardware side? Can they check if, for example, a security chip is present on the device, or is it just no, it's trusted?
I couldn't exactly hear it. Can you please rephrase it?
Oh.
Doctor?
Can you hear me?
Yeah, I can hear you, but...
okay, can you...
So, yeah. Is it better now?
Yeah, better.
Okay. So the question is, can you, as a app developer, can you check for some hardware features embedded on the device? Or is it just the bootloader is being locked and unlocked?
Since we own this server and all the implementation, we can improve the backend to show more information to application developers. For now, it's only the bootloader lock and AVB signed keys. Is it generated from T or not? But later we can add more policies. For example, is there any changes on the hardware, or as you mentioned, or is there any extra framework is running into this device? These all can be added later. But for now, we are following exactly same as Google.
Any further question in the room? Yeah.
Thank you very much. Also, thanks for me for this very interesting presentation. I actually have two questions. I'm not very technical, but I keep on hearing you're talking about a server. Is that going to be more like a federated system, so it doesn't depend on just one server? And the second question that I have is, we have quite a large community, and I would actually love to broadcast and tell everybody about this. Is there already, or is there going to be a very simple website where even a CEO of a banking app understands what he needs to tell his staff how to implement this?
Of course, of course. Yeah, the all the server is going to be federated. It doesn't have to be only one. And for showing, and we have a website, uattest.org, which also Mr. Sinha, our developer in Volla, implemented a new nice animation to it last night. If it opens, I can show you. It is also hosted on GitHub pages. Sorry, my computer gets too slow right now. I'm running too many applications. Come on. Yeah, uattest.org. You can maybe open it on your phone. Let me test it somewhere else. This is our website. Uattest.net. I'm so sorry. Yeah, I'm sorry. Yeah. Yeah, this is the attestation, unified attestation. Here's the architecture, how it's working, unified backend, app server, Android system service, end-to-end flow, token, how is the token generation, key APIs, SDK and services, how to run it locally, and how to run it on the Docker Compose files are inside the backend. We have a wiki as well. It is a very simple wiki, but I try to put as much as information I could for installation guides and config file explanations. We have this much, but it is greatly appreciated if any developers wants to join to this project to contribute and add more into the documentation part or even technical part, implementing RKP, for example. It is much appreciated.
No one? Is there any question from the YouTubers? Not yet. So YouTubers, the YouTube followers can also ask a question right here. We also there is a community proposal that certified devices can certify other devices. Maybe you can quickly summarize this proposal, Mr. Abdi.
Yeah, the microphone is off, or I'm not hearing anything.
My microphone is off. Okay. Can you hear me now?
Yeah. It's working.
Okay, my question is: there was a proposal at our GitHub project where we published the source code that was about that a certified device can validate another device. Maybe you can quickly summarize this potential and this
Of course.
proposal.
We have a proposal on our GitHub for not only using trusted third-party laboratories to verify and run these tests to make sure your device is running on a trusted environment. There is a proposal to use another device to attest another device. We can run all these Google tests. I'm telling Google, but it is all open source. The CTS security tests inside a trusted environment, which is another Android device, and a trusted device can attest another one. We call it a peer reviewing. Technically, it's possible, but it is not implemented yet. This is going to be very helpful for custom ROMs or small forks that of course they're not adding any malware to framework of their own forks, but they want to still use the banking application, for example. We can include all these custom ROMs into our backends and use this peer reviewing to make sure and verify this device is running all the tests and all the tests comes past the security as this device is validated, and the application can do the services. This is the proposal and possible solutions. Very great idea. It is not implemented yet.
And say something about the test suite that we could use. I think you mentioned it several times. So I think we would start to verify devices or certify devices. We will start with the existing testing tools from Google, right?
We will use the CTS, but for CTS tests, look, for example, in the CTS, you are going to test the whole device compatibility test. It has a camera, vibration, light sensor, and all this combined together contains millions of test cases. We are not going to run all of them for unified attestation purposes. Our only concern will be mostly security and framework addition, stuff like that. So we will going to run a minimalized CTS test. CTS, STS for security, the known exploits, known CVEs, and these all combined together can be a good verification for unified attestation. I think it is also a good idea to somehow expose the test results online for anyone who is curious to know what tests my devices pass and what not. So yeah, we are going to use this.
Not limited to Android. We have also some interested parties of the consortium. It's the UBports Foundation for Ubuntu Touch. It's Jolla for Sailfish OS, and Eclipse Foundation that is interested to host the project is mentioned, also IoT devices or automotive. So so the concept is open for other operating systems, correct?
Correct. Yeah. It is going to work on mobile Linux operating systems and basically everything that can run on a device that has access to the TEE and keymaster of the device.
Is there any question, additional question in the audience? Yeah, over there.
Thanks for a wonderful presentation. So when it comes to maintenance and development, what would be the costs? I mean, we have some interested state actor that we are talking with. I can't reveal the names, but the interest is there to have this work on a EU level. So they would typically ask for costs for this in terms of development and service and maintenance. So would there be any idea on that?
I think Dr. Furser can answer this question, but yeah, I can mostly talk about technical stuff. I'm not sure about the costs, but that would be nice.
Yeah, so since it's free open source, the usage is free. Maybe Mr. Abdi can give an estimation about the efforts for a developer. I think any developer who has seen the workshop could estimate its efforts pretty precisely. And if one of the states would become a host for this federated approach, then he could just run a server, and yeah, these are server costs. I think this is a low-end cost.
Yeah.
And I think I can say that we have some interested parties to become the testing institution. It's Arise in Sweden. We are talking with that they become the first trustworthy institute that is interested to do the testing for the certification. Concerning the development efforts, yeah, Mr. Abdi, maybe you can tell us something.
Yeah, of course. For application side, there's going to be changes on the APK for Android and application server. This is going to be very easy. In the presentation, for example, my test app was only 200 code of changes in total. But yeah, since the implementation is going to be very similar as Google, developers are already familiar with the whole idea and architecture. So I would say the cost and estimation is it's not that much.
Are there repeating maintenance efforts? I think after each app update or something.
I don't think so, unless we totally change the API. But no, there is once they implement it, it is going to be the same as Google. All the maintenance and updatings is going to be inside the unified attestation backends. For app developers, they only call the endpoint, and that's it.
Yeah, okay. I would say the effort for an app developer would be maybe a few days, a couple of days, and for the IT department of some authority, so they can make a 3-month project out of it to burn enough tax money. So. So that's more. Okay, so is there some more question? Okay.
Thank you for your presentation. I have a end-user question, and I totally accept if you say, no, that's not on my to-do list and there's no interest. But when I'm thinking about attestation, I would also be interested to get an attestation of my identity. For example, my ID card for special application services, my driver license for special applications and services, my health insurance card for special applications, maybe as well my age for being allowed to buy different things on a special store. These kind of attestations, would this be interesting to include into your solution as a game changer, or maybe a special criteria, not just copying what Google is doing in an open source project, but having something additional which makes your application more interesting for other people to use it?
That is a good idea. We can probably add more policies besides the device and application itself. But yeah, for now, it's not in the architecture. And even this open source architecture got a lot of controversy over the internet, I would say. But anyway, that is a good idea. We can look into it. We will we can implement it. The technical part is easy, but the legal part, how do you store the IDs? This is going to be challenging.
Yeah, that's yeah, that's why we have community days. Thank you very much. To that we get ideas how we can evolve and improve the whole approach. And I also would like to add that we discuss in the consortium that we may add further security checks even on the locally on the device to improve the security and privacy protection of the device. So this open source project that there's another European consortium that applied for funding, a very huge consortium with many European companies, and one of the working group in that consortium is related to unified attestation, and we also discussed this kind of things, how we can extend or improve the approach that of Google Play integrity by taking into account and that we keep or even promote a fair competition in the European market of free open source alternative. Therefore, I also welcome the suggestion at GitHub that we discussed briefly, that one certified device can test another one. As Mr. Abdi said, our initiative caused some controversy. That's okay. And I'm happy to all contributions and ideas to improve the whole ecosystem around unified attestation. We are doing that not because we love Google Play integrity. We do it to face the market as the market is. There are some app publishers who have chosen Google Play integrity, and we can't convince them to do it not. So I think it's a good idea to have this alternative that is matching the compliance of these publishers, whether they are banks or IT departments of public authorities. Okay, is there any further one? Okay.
Yeah, I totally agree with your statements about improving upon what is existing, and your suggestion was very good, and I believe that's something that government entities would love to have, because when they see what Google integrity is, it's not enough for them, because they don't want to rely on Google and even more an American company on this kind of topics. So adding those kind of features with public ID cards or this kind of age verifications that are coming into Europe recently, even if it's there's a controversy for this, for government it will be very interesting to have that, and we need to go further than what only Google is doing, because if it's just a copy-paste, what is interest for people, for developers to move to unified attestation? So we need an advantage, we need something more, and having governments on our side and giving them something that they need. And so they say, okay, it's just renting a server, that's fine. You provide the OS, we check it, we comply, we take part of the consortium, and that's fine. So yeah, good idea to build upon it.
Any comment from your side, Mr. Abdi?
Totally. No, I agree. No comments.
Yeah, so, and I think the idea is that we promote, as I said, the competition and also enable the alternative operating systems outside of the duopoly of stock Android and iOS, that they match the requirements of some app publishers. And maybe these app publishers will at the end switch to unified attestation, because in my point of view it's a kind of contradiction that the stock Android device is a privacy protecting operating system. Okay. Yeah, thank you very much. So we are again to you, Mr. Abdi. Maybe you would like to have some closing words from your side. So I
Thank,
unlock my
thank you so
speaker.
much. Thank you so much. Yeah, not much from my side. I would be happy if you guys have any further questions or want to contribute to this project. All available in the GitHub or Telegram. I'm happy. And yeah, that is it from my side. Thank you so much for listening. And I guess that's it from me. Bye-bye.
Okay, great. So now I thank you very much, and now we can switch to the next topic, the Volla open source projects, how you can benefit or contribute. I welcome another very senior developer. It's Mr. Sinha. And hello, Mr. Sinha, are you online? So let me then quickly check in our chat whether he is online.
Hello.
Mr. Sinha, you're here. Hello, nice to see you.
Nice
Can
to
you
see
hear me?
you, Dr. Wursner. Yes, I can hear you. Nice to see you, Dr. Wursner. And I'm happy to see all the audience at Volla Community Days. And thank you for having me really much. I would like to thank Mr. Abdi for such a great workshop on unified attestation. Now we move forward with the program, and I would like to go with my workshop. But before that, a quick introduction about myself. Myself, Aryan Sinha. I am a senior engineer, technical product manager. I co-lead the development of Volla OS, Abdi, and I also put some insights on the hardware development when we are developing new products. And today I'll be talking about Volla open source, how you can get started with Volla open source, and what are we doing innovative with the open source to enable development of custom operating systems on our devices, and Volla OS development entirely. So let me start by sharing my screen. 1 second. Yep. Is my screen visible? Okay. Yeah, so what is the philosophy of the Volla development? So we have a philosophy that freedom through simplicity and security. But this is not only what we ship to users as devices. This is also our philosophy on how we build our operating system. Open source is how we keep that promise, and so that it's verifiable and we are accountable to the people who are actually using our devices. There are 4 ways on which we build in the open source. Number 1 is open source and giving back. The entire Volla OS source and every patch we make to it is published, everything on our GitHub. Number 2 is kernel sources and portability, and the entire kernel stack is released, and so our devices can be ported to other operating systems. Then we have monthly security patches, and an answer to a very important questions. Why is Volla OS let's say a few months or a year behind the Android releases? We will deep dive into this more with the upcoming slides. Yeah. So let's continue with number one, which is open source and giving back. Yeah. So let's first talk about the Volla OS source. The entire Volla OS source is again open source. It lives in our GitHub repositories. This is our GitHub organization, where we open source all the components, not just the Volla OS, but all the applications and all innovations we are doing in the market. How is it built? It's based on AOSP, Android Open Source Project as foundation, but without any Google services or their cloud implementations, their applications, or their APIs. There's nothing hidden at our operating system layers. You can browse it, you can build it, you can validate it on your Volla phone if you want to build it, and you can confirm what exactly runs on your device. And as I already said, it's one home for everything. You can visit our GitHub organization, which has 30 plus public repositories, even more. And we have been doing this not just in past few years. We've been doing this since the inception of Volla, since it's been started. Yesterday, Dr. Forstner unveiled Volla OS 16. If you might have all remember, it comes with all the exciting features, optimizations, security improvements, and everything. And I'm really happy to announce that the Volla OS 16 source code is already open source. There is no delays, there is no waiting, and the full source tree is already live on our GitHub right now. We announced it in open source the same day. You can build it if you want. You can validate it on your device, on your own Volla devices. There is everything available that is required to build Volla OS. Yes, again, how is the Volla OS modifications made open source, right? So, and why we do it, right? First of all, the reason why we do it, it closes the loop between the people who build the operating system and the people who depend on it. So there's a transparency between the Volla development team and to the users who are exactly using that code base. Think of it like you know what code or what implementation is running on your device and how it is implemented. You can improve it, you can study from it, and do a lot of things from it, right? So as developers, we change the source code, we implement fixes every month, we implement some features, some hardening, and we push it to the open source. And users and community can verify it. And we are the very few, I would say, people in the market who are doing this. This is really rare because our trust is not only earned via word of mouth, it is also earned in code. You can validate and verify everything. So this was all about the how we go with the Volla OS source code. Now we talk about the kernel sources and portability. See, to build an operating system or to understand how an operating system works, only the operating system code is not complete. You also need the kernel sources for your device to build or bring your operating system to that device, right? So we just not open source the kernel, we open source the entire stack. You might be confused why I mentioned the word entire stack. The reason is, if you go to 3 years ago when we were using downstream kernels, really downstream kernels on Android, not us, but Google was using it. All the Android devices were using it with sublevel 4.14, 4.19, and so on. At that point of time, all the kernel and its requires dependencies were just built in the kernel image. But now, as the time proceeds, a new implementation was developed in AOSP. It's called GKI, the generic kernel image. So now the kernel is a generic image that can be run on many devices, which is using same platform. And the device-specific changes, for example, the touch panel drivers, the audio drivers, or the drivers which are specifically made for the certain device, is now split it up into the kernel modules and vendor modules. So we are the really few OEMs who are releasing the end-to-end source code for our devices. And we are also providing a brief documentation about it on how can anyone, not just a developer, who has a knowledge about Linux and systems can open that documentation, which I will show you later in this presentation, can open it and then understand from it and then build it. Completing this, building on this, Volla OS 16 device kernel sources are open too. And for our latest generation devices, Vodafone Plenius and Plenius Plus kernel sources are also open source. As I said, with full build manifest, comprehensive build documentation, so the developers can get on fast. As soon as they receive the devices, they already have the source code to build upon what. And for Vodafone Plenius Plus, we have also open sourced the PogoPen driver, which yesterday Dr. Bushnell talked about. So you have the CAD file to develop the accessories for Vodafone Plenius, and now you have the PogoPen kernel driver included into the open source as well as we have developed a very detailed documentation about the PogoPen, about its controls and how it works. So it will be easier for developers to understand the protocol and then implement it on whatever they are trying to do. So this is something which we are doing. And not only we just released this kernel source code, a lot of effort on Volla OS is also to keep the device updated and mainstream. So the Vodafone Quintus, which shipped initially with 4.19 kernel, is now upgraded to kernel 6.6 as well. And it is already rolling out in the beta channel. And with the Volla OS 16 stable release this month, it will be also be available to other users. And of course, its source code will be also available on our Git organization. As I was talking about, this is rare among OEMs. Because we released a complete device source, Vodafone is not locked to Volla OS or the operating systems we offer by default, right? We have also the multi-boot feature on our devices. So for example, you as a developer want to develop the operating system of your own or a known community-driven project. For example, we have Sailfish OS for our devices. And this was possible because we have everything available open source, right? And similarly, if you are a developer, you can use the source code which we provide to port your own operating system to Volla devices. And we will be happy to support this entire effort to, and maybe if it's compatible, we can also include it into the multi-boot application which we have. So you have not only just Ubuntu Touch as a multi-boot, you can have many alternative operating systems in the future. So yeah. Again, we have step-by-step documentation to build our kernel. There is clear prerequisites defined, what tool chain or environment you need to build it. What client version, what GCC version is it, right? And all the commands are properly documented on how you can build it. And then the result will be you will have a bootable kernel. And this gives you flexibility. You can also experiment it on your own. You can send some improvements if you have made to us using the pull requests. You can also try to play and tweak with all the drivers under the safety parameters. So it gives you an extended control over your device and your phone. Now, one of the most innovative things we have been doing from past few years is monthly security patches. And it is a great feat, in my opinion, that we as a small company are building on it and we have accomplished this. I think it's been more than 2 years we have been giving monthly security updates to all of our devices. And it's not only just the newer devices, even our older devices like Vodafone 22 and Vodafone X23, they receive this monthly security updates. So how is these monthly security patches integrated into the Volla OS source code, right? So I will tell you, give you a brief overview on how the entire process works. Every month on 5th or 6th, usually it's in the first week of the month, the AOSP drops a security bulletin. What is a security bulletin? Security bulletin is basically a patch which includes the CVEs or the vulnerabilities that was fixed in past month, which was reported by maybe bug hunters or discovered by other developers. And that is included into the patch, and that is released to AOSP. Once that is released to AOSP, we merge that code, that patches one by one into the Volla OS code base. And after merging those patches, we run internal sanity and test cases internally to confirm that nothing breaks, because even the security patches does not conflict with any feature changes or other merge requests, but it can still break something. So it is really important to run the internally sanity tests. So we run it, and then at the month end, we ship that patch update to our devices. So this is how it goes. Now answering to the questions that why Volla OS runs a year behind Android releases. And I have myself seen that a lot of developers, users in the community have asked this question, right? So the answer to this question is, if we don't ship AOSP as is, right? Between the AOSP release, which is done by Android Open Source Project, and Volla OS, there's a real engineering work that actually makes Volla Volla. Step one is we start by forking AOSP. Obviously, you fork the AOSP. What is the baseline? Let's say with Volla OS 16, we fork the Android 16 baseline. And then we strip out all the Google-specific remnants and de-Google it and cleanse the code base so there is no remaining calls that are made to Google servers or their APIs, right? Then we apply the Volla changes, which is security mode, our performance tuning, which we do, our battery life improvements, our security hardening, the features which Volla OS offers, unique features, our design changes, and everything. And then we base this code base into the final QPR, which is the most complete release. I will talk about this QPR more to let you all understand what exactly is this. So when an Android version releases, let's say Android 16.0 released last year, right? The Google has a quarterly release cycle of Androids. It is the first initial release is QPR 0, we call it QPR 0. And then you have QPR 1, QPR 2, and sometimes QPR 3, right? So if we base the code base into the QPR 0, which is the most initial release of any Android version, there is a high possibility that it has some incomplete or unfinished features or unfinished APIs, and see a lot of work in progress in that. Let me let you know that Google does not publish the exact stock Android they used on their Pixel phones to AOSP. They remove all the features and everything, and then they publish it. So the QPR 0, the initial release, does not contain a lot of them. But when we take our baseline as the final release of that Android version, which is QPR 2 or QPR 3, whatever is the latest for Android Volla OS 16, it is QPR 2. Then we work on the Volla OS over that baseline. As I elaborated in the previous slide, we applied our changes to it, and then the Volla OS ships a year later. So it's de-Googled, it's hardened, and it's tested thoroughly, and you get the most refined release of Android. So in my opinion, a year behind is slow, it's thorough. There's one more important thing which I would like to talk is longevity and sustainability. We support devices for years because our ideology is simple. Every device should get the longest, most extended support we can give it. Even the phones launched years ago runs our newest operating systems today without any compromises. There is no strip down on features or any other security feature of Volla device. this is better for you as a user because you have made investment bonds, and better for the planet as well, right? There's just two examples which I want to quote. For Vodafone 22 and 22 Pro, they launched with Android 11, and now they run Android 16 with Volla OS 16. This is almost 6 years of Android support. For Vodafone X23, X23e, it launched with Android 12. It now runs Volla OS 16. That's based on Android 16. Almost like 4 years of Android support. And sometimes this is not an easy task. Sometimes the SoC vendor or the SoC manufacturer, they don't, they drop the support of that device or that board entirely. So for Vodafone 22, we achieved this entirely in-house. Even for X23, we had no support from the SoC vendor. We implemented and backported everything on our own. Special thanks to Mr. Abdi. He worked on backports of the majority of the part. But yes, and we are not, with the Android 17, Google has removed the support of kernel 5.10 also, which runs on Vodafone X23. But we are going to support it with the Android 617 as well, because we have the capability that we can backport our changes and boot Android 17 on it. So, as summarizing, every extra year on device is one less device in landfill, and it's better for users and the planet. So yes, we talk about these 4 pillars, just summarizing them again, that the entire OS is open source, every patch is public and available to GitHub. The kernel source and device stack is also open source, so you can port your devices to our hardware. And we appreciate it if you submit a port of any operating system to our devices. Then we talked about monthly security patches and long support. And we talked about why we based on the matured releases. So it all serves one thing, in our opinion, which is transparency between the people who will build Volla OS and the people who use it, right? So yeah. And now the most important part, on how you as a user or you as a developer can contribute to Volla OS. Since everything we ship is open source, you can open your pull request, but I will recommend there's 3 places to start. Number 1 is device kernels. I already talked about it, that if you make an optimization or an improvement to our device's kernel sources, you can send a pull request to the device kernel repository. We will review it to make these repositories easily identified. We label these repositories per device, which you can find in our GitHub. And so, yeah. Second thing is our apps and systems. So even the Volla launcher and the every bundled app into the Volla OS is open source. Volla launcher, Volla messages app, Volla recovery, Volla cloud. Every other app we include in Volla OS builds are open source. You can find the specific repository names in this presentation, or you can find them on our GitHub organizations as well. They're also well labeled, and then you can build on it. And number 3 is, which is really new, we also invite developers to contribute to hardware as well. Since we have published the CAD design for Vodafone Genius Plus and its Pogo Pen accessory, the developers like you in the community can design the Pogo Pen accessory. You can understand its kernel driver, its protocol, and maybe develop a really interesting accessory we might not have thought of. It can be a solar panel based, some charger, or it can be something even more innovating. So yeah, we welcome such suggestions as well. Here is how you can build with us, this is our GitHub, our organization, our website. And if you have any questions on how to get started with the Volla open source or Volla development, or if you are, as a developer, are facing any difficulty on porting the custom operating system to our devices, you can just email me. You can find me on email. You can ask questions in our GitHub organization, and we will be happy to support it. Now I will show you some repositories or some documentation which we have developed. So you have a brief overview. Obviously, you can have a more detailed overview later, but I will show you a brief overview here. Let me just open. One second. Yep. So here is our GitHub organization. If you go to overview, yeah. So here is the Volla launcher source code, which is again open source. It's maintained by Dr. Wurzner, but you can fork it, and if you like to send us a feature, you can just use the fork button, fork it, and send us patches via pull requests. So you can see some developers have already sent it. If they want to make some improvements, we will review it, and it can be get merged. Now talking about kernel sources, this is the kernel manifest or the documentation which we developed for Vodafone Plinius and Plinius Plus. We give a very brief overview on how it can be built. These repositories are already included on the build manifest, but we obviously like to give our required repositories overview. And then we also share the information about what will be the prerequisites of this of building an Android kernel, which is Android source tools, Git, repo tool, and build dependencies. Then we have to make everything easy for developers like you. Instead of manually cloning all these repositories in these paths, we have developed this kernel manifest, which is a standard way on how you can implement, how you can make these repos trackable. You can just initialize this repository for kernel manifest and then clone the local manifest from Volla GitHub and then sync it. And then you can execute these build commands to build, let's say, Vodafone Plinius Plus kernel image, and your artifacts will be available in the out directory. And if you have any further, let's say, questions about how the repositories will be set it up, the repo tool will automatically do it. But still, if you are more of an enthusiast and if you would like to do something, you would like to create your own manifest or make some modifications, here is the project structure on how it should go on. And there's a contribution guide. You can make the pull request and send to us. Here also, we have developed the PogoPin documentation, which is available here. You can find it on this repository in the documentation folder, which is the hardware and driver overview of this Vodafone Plinius Plus driver. It gives all the information about how the signal routing works with the PogoPin. And our PogoPin hardware was actually designed in-house by one of our developer, Mr. Panier, so thanks to him. But this is a documentation on how you can develop your own accessory. And there's a brief information about what GPIO pin does and everything else about the driver, which is included in the kernels. So the developers like you can go through it and develop something of your own, which we will really appreciate, right? And similarly, the Volla Messages app, which we talk about every now and then, which is an innovative solution, is also open source. You can fork it and make the pull request to improve our Volla Messages application. Yes, again, the Volla Messages team is different. They will review your patches and then they will merge it. And similarly, we have Volla Recovery, and this is the main Volla OS source code, which was talking about previously in the presentation. This is the entire Volla OS 16 source tree, which you can verify and build on your own. The branches are labeled with the version they target. So latest branch is Volla 16, and you can view it. You can build. You can build Volla OS and verify it on Volla phone, whatever Volla phone you own. So this is the way we create a transparency between two users and developers. This is the entire overview about the Volla open source and how you can get started with porting your operating system to Volla devices. I would like to, if you have any questions from the people, I will be happy to answer them. Thank you very much.
Yeah, thank you very much for your brilliant presentation and an overview about all the projects. And I can say you have also another open source project, is Cypher OS, that is maintained by you. Also a very clean, nice operating system and open source alternative. Thank you very much for giving us the overview. And are there any questions from YouTube chat or in that room? Yeah, over there.
Thank you very much for this wonderful and very clear presentation. One question that has always been on my mind is, what if one day Google decides to stop releasing their open source software? What is the strategy then from Volla?
If Google decides to close source the Android open source project, it's not like we are dependent on them for everything, right? As I said, that we take the baseline from Android, right? But if, for example, let's say Google decides that they're not going to release Android 17 or 18 to open source. So we can still keep building on the Android 16 baseline, which we have right now, and we keep building on it, right? And you might ask that it might get outdated after some times, the APIs might get outdated, right? So we have a solution for that as well, right? First of all, we are not reliant on any of the Google's APIs or everything. We have our own implementation of everything, right? We are not dependent on Google for anything. We have our own Android servers, right? We have our own infrastructure for everything. As Mr. Abdi also elaborated, that we are developing unified attestation, which will be an alternative for an attestation written based on Volla devices and also on the other devices. So we keep building on the baseline we have if Google stops releasing AOSP. And if needed, for example, for some method or some application implement, we can also study and reverse engineer some things and try to implement it on our own. We have that capabilities in our team that we can keep that development without relying it on Google.
And I would like to give some addition on this. I don't think so that this will happen, first. Second, if that happen, we are an OEM. So if necessary, we will license it. And we also get not only it's not only the IUSP part that we get, we have the supply chain, and we get also updates from the SoC vendor, who gives us who creates the Android the Android source tree. Maybe Mr. Sinha can also summarize that process in the development,
exactly.
In the supply chain. So usually the SoC is creating the Android source tree, and then the board designer finally creates the Android board support package that includes all the drivers. All the vendors for some components are contributing to that drivers. So in summary, we have the Android board support package. It includes the Android open source system. It includes the kernel. It includes also the drivers, and this is more than 50 gigabytes of source code. So during the supply chain, we get the AOSP, and we also get not only security patches from AOSP, but also from SoC vendors. And maybe you can explain it more precisely, Mr. Sinha, we have now for the Volla tablets a new BSP with a kernel 6.12 that gives us a chance for long-term support of major updates. And the Volla Quintus, if I'm not wrong, has now kernel 6.6. So there's a long supply chain, and as an OEM, we have other sources, and if necessary, we can license and the Android open source project if it would become closed source. And I also would like to highlight that we have Ubuntu Touch as an alternative also for strategic reasons. If Android evolves in a way that doesn't match our philosophy and promise, then we will more promote and switch to Ubuntu Touch. We are ready for this. So Ubuntu Touch it's not only an option for the customers, it's also a strategic reason that we have Ubuntu Touch in our portfolio. Okay, maybe Mr. Sinha, you can sketch also the supply chain of the firmware and how way this is going. Yeah.
Yes.
Okay.
I agree. I agree with Dr. Wursner.
Yeah, this is an easy question. So did you understand it? So do we publish, what is the...
Release device trees for building custom ROMs.
Do we release device trees to build custom ROMs? So, or what is required to build custom ROMs? Okay, two questions, it's complicated. It's challenging.
Yeah, no problem. I will answer them one by one. So, talking about the BSP, yes. So building on what Dr. Wursner said, there's not only one source where we have the Android from. We have the board support package, which comes from our SoC vendor, and it does not even it includes the Android source code, but it also includes some of the low-level firmware drivers and its components, which we cleanse and then we adapt to AOSP. So, for example, in future, Android goes in the way we don't intend it to, we can rely on that supply chain which we have from our code designer and the SoC manufacturer to build upon it. And the BSP is basically board support package. It includes the Android source code as well as it includes a lot of proprietary firmware drivers, such as modem and other critical firmware binaries, which is needed for the device to talk with the hardware, which is needed by Android to talk with hardware. So yes, if we ever run out of solutions from Google, we also always have an alternative way to deal with it. And as Dr. Wursner said, if it comes, we can also license Android as we are an OEM. So yeah, answering on the second question, yes, we did release the device trees. The device trees are currently available for Vodafone X23, 22. For Quintus, we are working on we have already implemented the kernel 6.6 migration. So a new device tree for Quintus will be also published on our GitHub organization. And for Plinius as well, we will publish the new device tree on our GitHub organization. With the Vodafone Plinius and Vodafone Quintus, for the developers who want to port custom ROMs, we are using the GRF implementation. Developers who are familiar already know what GRF is, but let me just summarize quickly. GRF basically means that the vendor or the VNTK or the vendor image remains freeze at an older API level, and the system and all components move to the latest Android API level. So yes, we provide the device trees, and we, as I said, we also provide the guidance and support for the developers who can port their custom ROMs to our devices. Building on that, one of the interested party, which is IOD, has already ported their operating system to Vodafone Plinius. So it's all enough open that developers can, you and the community can build custom operating systems for our devices. Not just Android-based operating systems, but also Linux-based operating systems like Sailfish, Droidian, and so on.
Yeah, thank you very much for this answer. Do we have further questions in that room?
As well, thank you very much. It was a very structured presentation. So thanks for that. Let me narrow down my question by saying, if we look at users, end users, customers, we all live from customers. And what I know, what they are interested in is features, no failures, performance. We don't need to talk about features and failures now, but performance. If we are using an open source kernel, it is not using anything Google is adding to it for its own purpose. That would mean that our system, the Volla OS, should be faster than a typical Google Android. Are you measuring it, and do you have any performance information about the benefit by using Volla OS instead of anything else?
Exactly. As in the Volla OS, there is no bundled Google applications. If you have any smartphone that ships with the Google Mobile Services or GMS, they preload like 12 applications from their side, which are not necessary for the end user. And on top of that, some of the OEMs also bundle even more applications which are made by them, or they are just for advertising purposes, right? On the Volla OS, the operating system is really narrowed down to essentials at its core. So it gives the improvement on the performance side, but as well as it gives improvement on the battery side as well. Like if you have too many applications which is preloaded and they are using your data in the background, which Google applications do in general, they also drain your battery. We have not run definitive tests on our devices, like because we don't have Google Mobiles. We have never tested the Vodafone Plenius with Google Mobile Services inbuilt. But if you compare the device with similar specification in the market, like the Vodafone Plenius shipped with Dimensity 7300, if you find a similar device with Dimensity 7300 processor, and if you compare it, you can check the overnight drain, it would be way less into Volla OS because there are no services running in the background into the Volla OS operating system. And this just gives a performance advantage as well, because there are so less services, the performance is gradually improved. But we don't just rely on this for improving the performance on our devices. We also implement certain fixes and certain improvements into our code base to further improve the performance. These include some tweaks with the power hull, the power hints, and so on, and also the optimizations into the Volla OS framework as well. So I gave you an example of Vodafone 22. It is a very old device with only 4 gigabytes of RAM, but it still runs smoothly on Android 16, Volla OS 16. So yes, this is our philosophy, that to improve the performance and the experience for end user as well.
And it's about long-lasting devices. So if people with Vodafone 22 can still benefit from the recent features and from an end user point of view. And I'm also proud that we didn't forget the users of the first Vodafone and Vodafone X. It was this spring. In this spring, we published another security patch, although it wasn't supported by IUSP anymore. And we also included some new features, so the people from the beginning can have these improvement on their long-lasting Volla phone of first generation. And I want to also mention something else. It was a user who reported a comparison of his Volla phone with a stock Android, and he told us that he has 80% less data transferred. And it's because, as Mr. Sinha said, there are less background services that are continuously connecting computer centers of big tech to send data or to calculate some profiling, to modify or personalize some features. And this has also an impact on sustainability because our devices doesn't use so extensively computer centers with a demand of energy that is sometimes used of whole cities. So this is also some aspect that is not part of the public discourse about sustainability and is another benefit for Volla devices. Yeah, any further question in that room? Or maybe online? Yeah, okay.
Thanks for a wonderful, precise presentation. Okay, so with the Vollaphone Plenius, I think we see a new design strategy. We see it in modularity and also open source hardware. That sounds really, really promising. So could you perhaps reveal some of your future expectations and also some dreams?
Yeah. So this is the first. Yeah. So if we with the Vodafone Plenius Plus, yes, this is an exciting opportunity for all the developers that we have also open source the first hardware accessory construction via the Pogo pin, and I think it's exciting. And as more and more developers will get interested into our modularity approach, I think this way we can build a really strong community, and in future we can have even more further such modular devices and such projects that are made by community, which can be shipped into the production. So it's an exciting approach, in my opinion, and I think we are the initiators who did this with such modern hardware and giving so much control to the users. So these are my thoughts, but I think Dr. Wurzner can also share his thoughts about the same.
Question. We have already further devices in the pipeline that are new kind of devices that are not available in Europe with that specs. So we didn't unveil everything yesterday. So we are already preparing further exciting hardware for Europe and beyond. I can also tell that there's a huge demand from Africa, and we are also working here because Africa, it's a kind of Aufbruchstimmung. I don't know how to say it in English. So there's evolving a lot of business and economy. And we are also looking, we are investigating in offering devices in particular for India, and maybe with a modified and operating system for people in India. Maybe Mr. Sinha can share his ideas on it. And I would like to highlight that as an OEM, we also offer customized operating system in a B2B context. So I'm very happy that we have this successful relationship with your data network. It's very exciting what's coming up. The deep embedded mycelium, so that the smartphone becomes a part, a node of this distributed internet. I think it's quite unique. And we have another business customer, it's Accenture. Accenture is, I think, well known, and they have a medical concept. This is an emergency center with specialized doctors, and they can be called in an emergency case by the team on site that is called to an accident. And we made a customized operating system that automatically switches to the mobile cellular network with the best signal strength. And we collaborated with Accenture to do that, and also to implement the operating system for a custom device, a headless device that is part of the ambulance. So these are two, I think, exciting and different operating systems. We also did an operating system with Safety-E. It's a smaller German company, and we made a specialized operating system for fire departments. So with a special UI. The UI was very simple, very fast. So when the fire department was called for an accident, the firemen and women get the information about the car involved in the accident, so they can decide with which vans they go to the accident. If they're an e-car, an e-vehicle, they need to be very fast and maybe have with other trucks need to go to the accident, or they instantly know where to cut out the injured people from the car. And this special UI and this special system saved up to 30 minutes and more for an accident, and this really rescue lives. It was a very nice project that our team did. So I also motivate all the B2B customers listening that we can also tweak the operating system for your needs to have really competitive business solution. Yesterday, YNC, Virtual Network Consult, or most people know them just by YNC, Logan. This is their product. We developed the YNC phone that has pre-installed their apps for the replacement of Microsoft 365. And this is also a wonderful partnership. So they can offer business customers, large organizations, a full solution for a secure working place. Also, Bechtle, Switzerland is offering this full package for this, they call it a secure workplace. It includes the Microsoft replacements and many other things. It contains mobile device management and such things, and this tailored OS, they call it YNC phone. So I think this is also a good inspiration. And corporate customers can use the open source as well. And even the PogoPin, the modular approach is perfect for industry solutions. You can snap on an industry scanner for stock solutions or for production solutions. So this is, I think, should inspire people. And the Volla Cloud is open source. We learn after the lunchtime an introduction. It's not only for end user and consumer apps, it's also for apps for the industry. You can use the Volla meshnet with Volla Cloud to control and maintain your machines in a machine park for Industry 2.0. You can make distributed predictive maintenance with our AI. So there are a lot of opportunities by this open source. Okay, any further questions from maybe from YouTube or not in the chat? Maybe in that room, maybe from Ubuntu Touch. Ubuntu Touch is also, we are contributing, our strategy is that we are very happy that Ubuntu Touch is open source. So we have some device-specific parts. Our engineers are working very hard on it. I'm pretty sure that Claude will help us to be more efficient and to do such things even in a small team. And we contribute also to the generic Ubuntu Touch. So this is also part of the open source philosophy. We contribute to even to open source project with security patch. So we contribute back to open source projects that we use, like also Ubuntu Touch. Hardware adoption is a hard work. Maybe we discuss with the Eclipse Foundation, maybe we can create a device that can be used with a mainline kernel so that the hardware adoption will be even much more easy. So this is all on our roadmap, all in our negotiation. Yeah. Thanks to the open source community, thanks to the merge requests, pull requests from of developers from the community, and also some people, just consumers, they just post some ideas or requests in our GitHub. Thank you very much for this. Yeah, I think if there's no further question, so then I think we will start. I think it's a quarter to we have a 12:15, but we restart the next workshop at a 1:45. And it will be a very exciting workshop about Volla Cloud apps. Volla Cloud Service, how to create a Volla Cloud app, or maybe to contribute to the existing Volla Cloud apps, Volla Recovery, Volla Messages. Volla Messages needs much further features. The next feature, I think we can publish it as a pre-release in the nightly repository of F-Droid. That will be a release with audio and video conferencing. We have already started on moderation. Moderation will be a big epic for Volla Messages. Volla Messages will be published as a first stable release in July. This is my expectation. It's close to be published with the basic features for private messaging with trusted peers. And to use it as a Telegram alternative, we definitely need a moderation to kick off some clowns of some channels and open discussions. So thank you very much, Mr. Sinha. Thank you for your contribution to the Volla team, your initiatives. I also want to highlight it was your initiative to bring in open source re-implementation of GameSpace, to switch off all the battery saving features and energy saving features just to get all of the performance out of the device, to have the best gaming performance, to burn it down, your device, but have the highest score. And thank you very much for your contribution. Maybe a last statement from your side.
Yeah, I would just like to thank all the Volla members on site for the effort they did for this Voila Community Days, as well as my colleagues and all the developers who have helped us. And lastly, thank to the community and to Dr. Wursner. Thanks. Have a nice day.
Thanks.
Bye.
And at this point, thank you very much for your effort. Also, thank you very much for the video broadcasting team, Mitteldeutschland TV or Mid-Germany TV. So thank you very much for broadcasting. You made also a very good job. And also for the audience in YouTube. We are back 1:45, and I'm looking forward to the next session. Thank you very much to the audience for your patience and your questions and inspiration. See you soon. Bye-bye.
development will
So it's good. Rajanan should at least have a Volla for Pliny as soon as possible, and also the other.
I would ask for them. What's the limit? Because if everyone says, "Yeah, what time?"
Yeah, I told him we have 2 free devices or 3.
Straight.
And and then you
By
can,
buyers.
and others can have any developer has 20% developer discount.
Okay.
Mhm.
Okay. I will give the information of the development group. So, and I will see to have an answer for you.
Perfekt.
Thank you.
Good trip.
Have a nice day.
Tschüss.
Thank you.
So, dann fangen wir wieder an. Ich hoffe, dass willkommen zurück zu dem Nachmittagsteil vor einem sehr spannenden Workshop über Volla Cloud Apps. Und ja, lassen Sie uns wieder die inspirieren durch ein bisschen Musik. Frau Funk ist wieder hier und gibt uns eine kleine Inspiration und sagt uns auch, was sie spielen wird. Und dann steigen wir gleich ins Programm ein, was dann der Workshop wieder von Herrn Gaberi gemacht wird und mit Online-Unterstützung von Herrn Esmailipur. Ich hoffe, er ist online und vielleicht sogar auch Herr Harris Brown. Aber zunächst erstmal Frau Funk, dann los geht's.
Also ich spiele heute 2 kurze Stücke von Michel Porret. Einmal das Menuett und einmal eine Liebe.
Lebensgeister und Konzentration. Ja, so, dann starten wir jetzt in den nächsten Workshop Volla Cloud Apps und ich denke, Herr Gaberi, Mr. Gaberi, you are ready and so maybe you can start. Yeah, you can go here, but anywhere you want, where the cameras can find you.
Okay, so I go here, for example.
Oh, I think you can also over there sit. Huh?
Yeah, I mean.
For the camera, should he say you there?
Er sollte sich dann hier hinsetzen, oder?
Hier, ja.
Hier so, dass die Kamera quasi auf ihn.
Okay. Okay, can you hear me? Yeah. So this is the workshop on how to create a Volla cloud application. Okay. Okay. So this is the workshop on how to create a Volla cloud application, and it's divided in two parts, one done by me and one done by my colleague remotely. And the part I'm gonna cover mostly focuses on how to create an application written in native Kotlin, and in this case Jetpack Compose, but it can be written in also with XML views. And the other part will focus on how to write an application that still uses the Volla Cloud Service, but is based on Tauri, which is another technology that makes it easier to make the application cross-platform. But obviously, for example, for the Volla Recovery application, we had to use a native approach since it integrates better with the barebone components of the operating system. So for example, in this case, the backup process. And I wrote an example application for this showcase. This application basically just connects to the Holochain service that is already running inside the device as the Volla Cloud Service. And after authenticating in this service, it then sends a sample message that calls the home. So to start, we should explain the various components of Holochain. And let me just, okay. The various components of Holochain and how things are divided, because there are quite a few different sections that basically interact together. So as usual, in any application, we have the regular Android application in Kotlin, which is the most abstracted layer, so the higher level layer. But then we can also integrate more deeply with the system. In this case, there are two ways to interact with Holochain. And one is through their JavaScript library, which is the one that is used in the Tauri projects. And the other one is using the Rust client library. Because basically how Holochain works is there is the central piece, which is the conductor, and the conductor is contained in the Volla Cloud Service, which is already installed on the device. Then an application that wants to leverage this service is going to install his own application, which is an age app file, in this case, age app bundle. And let me zoom a little bit, maybe, okay. An age app bundle, which is basically a collection of Rust code that gets compiled into a web-supported way, into WebAssembly, which is basically assembly but for the web, running inside web containers. And then those packages get installed inside on the conductor, and then you need to find a way to communicate with the packages, with the applications once they've been installed into the conductor. And use that, to do that, you use the clients. So in this case, we are using the Rust client because it's almost impossible to use the JavaScript client from a native Android application. and so we need to go to the lower level and use the Rust implementation. In this case, so the two Rust components we have in our project are the client, which interacts with the conductor, and the DNAs, in this case the example zones, because the zones are the pieces that go inside the age app and then that goes inside the conductor. So the zones are divided into integrity zones and coordinator zones. And basically, to put it simply, the integrity zone is what creates the rules that you have to obey, and it basically creates the base structure of that little piece of code. And then the coordinator zones are what allows you to interact with that bare bones code, because you have all the various functions and methods that you need to call to make the various things in the zones. And so the integrity zones are crucial because whenever you make a change to an integrity zone, you change basically the DNA of your application. Once you change the DNA of your application, basically you have to migrate your data each time, because it's like you are modifying the database and you need to migrate the data to the newer version. Meanwhile, you can actually modify the coordinator zones without having to change, like to reinstall the application or anything, because those are just functions built on top of the integrity layer. And so we can go maybe a little bit more hands-on here and show a little bit of the Rust code. Okay, so I will show mostly the client code, because for the zones there is a lot of documentation provided by Holochain. So if you go on developer.holochain.org, there is, yeah, it's lagging a little bit. Okay. On developer.holochain.org, you can find all the documentation on literally everything, especially the starting steps, which are basically to use the scaffolding tool to create an example zone and then go modify the code, study the code, and modify on top of the scaffolded zones. And instead, you can check out the example project that I was mentioning that is on the Volla GitHub. I will show you in a second. Because here there is all the layer that allows the Android application to connect to the conductor and then actually call the various functions that we have inside of the zone. So we have the WebSocket, which is basically just handles the initial connection to the port where the conductor is opening up a port and then allowing you to connect to that port to communicate with the application. And this is very easy because it just leverages the client created by Holochain with a connect command. Use the local host, which is just basically your machine, and then a port that you provide inside of the parameters of the function, together with an auth token and also a signer, because you need a signer to actually sign each call you are making to the application, because that way obviously makes it more secure compared to having an unsigned thing without any authorization token or anything. So during the connection here, you need the authentication token and the port. So let's go over to the Android side, because the port and the authentication token are basically retrieved from the conductor itself. So the library that we are using here is the Holochain library that I can show here. No, wait, here. This is the Holochain client library, org.holochain Android Service Runtime client. And this can also be found on the GitHub Volla repository. And so the way we use it is basically, okay, the initial connection is basically done with connect setup app. When you run this function the very first time, basically you will get a pop-up from the Volla service, Volla Holochain service, and that pop-up will then allow this application, the one you're working on, to connect to the Holochain conductor service and then install its AGAP file in it. So in this case, we created a payload here with the source. The source is basically just the bytes that are actually making the AGAP, because the AGAP, once it's been compiled, has to be included in the application as an asset. So you have the bundled bytes, you just include it in the source, then the application ID, which is the one you established during the scaffolding process. The network seed is just a random UUID. Even if you don't set it, it should automatically set a random UUID. But yeah, here I'm just explicitly randomizing it. Role settings, just an empty map works fine. And then the agent key, this is basically the key you use to sign each call. And in our case, we generate this key at the first time the application is opened, because it's easier signing things locally instead of getting the application to sign them, because the process of going back and forth would be a bit complex. But yeah, without explaining too much about the details, here's the whole code, and it's publicly available on GitHub. And then we can go back. Okay, so here, then when we initialize, we connect setup app, which is basically calling the conductor, and the conductor will return us an app out. The app out contains the port and the authentication token, as you can see here. And so this then is passed onto Rust, like we mentioned earlier, and allows the initial connection to the service. You also need some permissions in the application manifest for that, that we can see here. Yeah, mostly the internet permission and the queries permission to be able to call the other application locally. And yeah, that should be, also the users clear traffic is really useful for the WebSocket, otherwise it's gonna not work usually. Okay, so here we have the function, sorry, it didn't switch yet. Okay. We have the function to call the zones. Basically, I mean, this is just a base layer, and then the other functions that are more higher level are based upon all of these. So, for example, if you then switch to the example client, the call zone function then basically delegates to the functions that are lower level, and yeah, here you, for example, this function greet is the first proper method that you would actually want to call from Android, because the greet method is just an abstraction that then creates the payload. Here in the function, you just pass a simple string as the message of the greeting message, and then the function creates the payload and then calls the backend zones, basically. And here, this one, I mean, the whole flow is a bit complex because, yeah, there are a lot of calls that have to go through a lot of ops. And this call zone, for example, then calls the actual DNA that we have here in the code, zones coordinator. Here in the library, we have the greet function, and this is what is actually getting called inside of the DNA once we execute the other greet function here in the client. And what we are using in this project is the Unify, it's called. It's a project from Mozilla, which a lot of people know because of Firefox, but they actually also contribute a lot to open source projects. And this is basically a bindings generator that allows to generate the bindings from Rust to Kotlin. So basically, you generate your libraries that you compile from Rust natively into an Android.so library, and then you can just call the bindings in Rust to call the actual call the bindings from Kotlin to call the actual Rust methods that are in the backend. So basically, this is what we are using, and it's very intuitive. There is a lot of documentation on this one as well, explaining how to how to approach the whole project. And then there is also another alternative, which is Bolt FFI, which is a little bit less stable, but it claims to be a lot faster than Unify. Obviously, the structure is a bit different, but it also has a lot of documentation. Both projects are just open source and available under MIT license. And so let's go back to the code for a second. So here, yeah, the grid command, just as you can see, the structure of the cosome is the cell ID, which is basically each time you copy the age up inside the conductor, it creates a new cell. So then you have to pass the cell ID to actually make a call to the precise cell you want, because one age up can also have multiple cells because of cloning, which is something we use a lot on the Volla recovery application. So you just need to call to specify the cell ID, the name of the coordinator zone, which in this case is just example for the application, and then the name of the function, which in this case is grit, and have a payload. The payload needs to be formatted with RMP-SERD, because it basically serializes the payload and makes it readable then for the deserialization that happens automatically inside of the, I mean, in the holochain conductor, the zones read the messages automatically, deserializing them. That's why the input of the function is the string itself and not the serialized version. So, yeah, that's most okay. Then, for example, here we have a function, I mean, some functions to, for example, check if the service is connected to the WebSocket, if the connection is stable and everything, which is very useful when we want to check stuff from the Kotlin side. Otherwise, it's a bit complex to check if the connection is actually active or not. And also a function to get the provision cell, which is the first cell you clone. So the initial cell when you install the application is the provision cell, and then if you want to clone cells, that's called the clone cell, and it goes from 0 to however many you need. And so yeah, having a method to retrieve the provision cell ID can be very useful, because you basically can use that as a sort of database and never share it with other peers, because it's pretty hard to share this cell and get other nodes to talk with this cell. Usually just talk with the cloned nodes and not the regular cell. Then here is the local signer. That's just to sign the zone calls. It's pretty simple, and you basically pass the private key when you initialize the service, and then just stored in the Rust memory, and it gets used, but it doesn't get saved anywhere. It still stays inside the key store and nothing else. It doesn't go anywhere else. And so yeah, this is basically the whole flow of the application. And then from wait a second. Okay, here. From the main activity, you can then call, in this case I'm not using a view model because it's just a sample application, I'm just using remember in Compose, but you basically initialize the holochain service client, just passing the context and the bytes of the age app that you're about to install. And once you do that, you have initialized the service, and then when you actually need the connection to be done, you can just call the connect service client. This is a bit of an abstraction that I made inside the client, because it allows to connect without explicitly trying the connection every time, because without trying to install the age app every time, because in this case it just connects automatically. And then you just need to reconnect in case you needed the authorization or anything like that. But yeah, this was most, and here you can call the greeting method, because the greet method also has counterpart in the Kotlin side, so in the holochain service client here. And here it's yeah, in the binding. So here you can see the logic of the binding from Rust to Kotlin, because it's all pretty complex low-level logic. This is all automatically generated file, because Unify basically automatically generates the bindings and also allows you to compile the libraries to then use it into the Kotlin side. And I will show the repository. Yeah, here is the repository in the Hello Volla GitHub organization, the Volla Cloud example repository. We just made it public today for this, if it switches. Okay, this. And yeah, this can be taken as a perfect example to have an initial working application in the using the Volla Cloud Service. And yeah, basically the cloud service, last quick thing, to have two devices communicating, you basically just need to have both with a matching DNA, which means that you basically have to clone a cell and then have the same identical parameters on the other cell. This also includes, for example, so-called membrane proof to join the cell, and that can be seen in the Volla recovery application very easily, because I have implemented a ZOM exclusively for the membrane, and that shows exactly how to implement it. And yeah, that was my presentation, and I hope you enjoyed it. If you have any questions, let me know. Thanks.
Ja, wunderbar. Dann thank you very much for your presentation.
Of course.
And we have github.com/hellovolla is our site, and I think developer.holochain.org.
Yeah, it's the Holochain site. Yeah.
Holochain site. There you find some initial videos and documentation about the Holochain part. That was how to, because we have this special setup that you have a lightweight app that deploys something into the in the Volla cloud service, right?
Yes, yes. And the Volla messages also add, I'm not sure if we are still using that on some devices, the version that is with the conductor inside of the Volla messages app, but that is of course less like convenient compared to having a separated application that acts as a conductor, because otherwise every single application would need its own conductor, and it would also take a lot of space on the device, and also it wouldn't be very efficient to sync 4 or 5 different conductors, which is one for each application. It's a lot more convenient to have a single conductor and install the age apps inside of it, and then just have it handle the whole syncing mechanism on its own.
That works very well. On my test device, I have registered Volla recovery and Volla messages. So that's the idea. Yeah, is there any question from that room?
Yeah, sorry if it was a bit technical, but also for the people at home, that's what we wanted to do.
And maybe online, is there someone who has a question? Maybe you can prepare the question, because we have a second part of the workshop. It's hello, Mr. Ismailpur. Let me say whether he's online. Hopefully, I can see him.
Yeah, I think it's online.
Maybe you can say hello. Ich weiß nicht, ob es eine Frage der Regie ist. So, hello, Mr. Ismailpur. Maybe you can talk. Yeah, here he is.
Yeah, wait, maybe it's muted, I think.
He was muted, did you?
No, I think maybe the PC, because I didn't hear him talk.
No.
No.
Hello.
So, hello, now I can hear you. We have a...
All right.
So, maybe you can start with your presentation.
Okay, let me share my screen. Hello. Can you see my screen? Okay, I'm sharing.
No, yeah, I think that's his screen.
No, this is a placeholder, I think. Or is that a headline?
Same holochain idea.
Yeah, okay, now we can see it. Yeah.
Yep.
It's very minimalistic. Perfect.
Yeah. Okay. Thanks to Mr. Gabari for explaining the native Kotlin Android side of the implementing an application based on Volla Cloud Services. I want to, explain the point of view of Tauri implementation of the Volla Cloud Services. It's the same idea of the holochain, but it's a different shell. Volla messages with Tauri architecture, it's because we can have cross-platform application all devices such desktop, web, Android, and the other build type of the application. The volume messages is on two build type, which is the rich version on Android side, I'm telling. The rich version and the light version. The rich version has the conductor in its source code, and we use the holochain conductor in one bundle application. So think of Tauri as a picture frame. The picture is your web app, which include SvelteKit framework, HTML, TypeScript, and the Tauri just a frame that turns this a stack of technology and framework into a native application. Gives it an app icon, an installation package, access to the camera, clipboard, file system, and etc. Without Tauri, it's a website, but when you use Tauri, you have an application that you can install on the Android OS platform. You can see the stack of the architecture of Tauri. We have a SvelteKit UI web view, and after that, it's Tauri shell that includes some system permissions like native capabilities. Here, we divide it in two ways, bundled and light. As I said, the bundle includes the holochain conductor service, but the light version uses the Volla Cloud Services, which is an up and running application service that is running on the Volla OS. So in the next stack, we have HApp and Zooms. Zooms include two type of code, the integrity and the coordinator. The integrity define the type of the variables that we want to use in our project. And the integrity makes those types to functions, which we call API. And we can use those functions as an API to develop our application. Tauri in plain words, as I said, we can think about Tauri as a framework. And you can see we can use Tauri installable application on OS platforms. As you know, in holochain services, there is no central server holding user data. Messages, keys, and app state live locally first. Holochain synchronized through peer-to-peer networking using bootstrap servers, signal servers, relay servers that we embed them into the application. The front end uses normal async calls such as call Zoom. As I said, the API that we wrote with integrity functions. And after that, holochain conductor locally run in our system, and the database, it's inside the conductor, which we say the database DHT, data hash tables. And every phone have this DHT on its own, and every phone seems like a peer, and we can connect to this peer and fetch the data and send the data to them, and vice versa. The bundle build include the Tauri plugin holochain, which use the conductor inside the bundled application. Because we need to communicate with the holochain conductor, we need to have some plugins in Tauri. We use Tauri plugin holochain that this plugin is developed by the holochain team, and they use this plugin to communicate with holochain conductor in bundled application. It starts its own conductor, uses configured storage path, and owns network config, and we embed the network config inside the application and inject the right app socket into the UI. And as you see in the bottom right, we use these servers to communicate with the peers and signaling and other stuff. This is the diagram of how bundled startup sequence working. Loading plugin is the first place, and after that we start conductor. And after starting the conductor, we install or update the Edge app. Maybe sometimes we have a new version of Edge app and need to update that. And open authenticated web view, because Tauri works on a web view, and you see all the implementation of the code as a web view. And UI connects with no URL, because the UI, there is no need to see the URL. The plugin hides the conductor setup from the Svelte kit. Because of this, when we change the UI code and source code, there is no need to close the app and often start it again from the scratch. You can see it like when you are developing a front end on the website, you don't need to close the server and start the server again. For that, in this application, we do the same. We don't need to close the server and start the Edge app and the conductor again. We can see the changes real time on the front end. Holochain, all these configuration are on the ROS codes. Holochain bundled.rs, it's a ROS code for bundled application. Load Tauri plugin holochain, and we use that plugin of Tauri to connect to the conductor. And here it's the architecture of the light version. The light version doesn't include the conductor. It uses the Volla cloud services that the conductor is on the Volla cloud services, and we connect from light to Volla cloud services with Android IPC and AIDL. What include Volla messages light is just the Tauri, the UI, and the front-end stack of technology. But here, there is something else that we need. It's Tauri plugin holochain service client. In the bundle, we just use Tauri plugin holochain, but for communicating with Volla cloud service, we need another plugin, which is Tauri plugin holochain service client, that connect the light version to the Volla cloud. And the Volla cloud service is a shared holochain conductor, and it's always up and running in our Volla OS, and we can use that conductor to start the application, the light application. The service mode is same UI but different ROS code. As I said, in the holochain services, in the holochain bundle.rs, we use all the configuration. We have all the stuff to communicate with the conductor there. But here we have a service client plugin instead of bundle conductor plugin that help us to connect to the Volla cloud services. Same front-end API, app WebSocket connect to and zones call, and after that signals are signaling to gossiping and find the peers and send the data through the peers. The difference is entirely below the UI. Bundled mode starts a conductor. Light mode asks the Volla cloud service to run the conductor, because here in light version, Volla cloud service has the conductor. The difference between light and bundled, which we called it rich version, we have two type of Android version for Vola messages. Rich, which is bundled, have conductor in it, and the light, which is communicating with the Vola Cloud services, and there is no conductor in it. The Tauri app itself do all this stuff, but in the light version, Vola Cloud services is always on the Vola OS platform, and we use that service application. Network configuration set in holochain bundle.rs, which is a ROS code that we use, that we set all the configuration of the network there. But in the light version, we use the configuration of the Vola Cloud services. The startup time in bundled obviously is slower because we have to boot up the conductor every time that we use the app. But on the light version, because the conductor is always up and running, we don't need to boot it up when we want to use the application. It's already boots. It's already booted up. And the battery resources, it's lower on the light version because of that conductor processes on the application. And code size is much smaller on the light version because most of the code, most of the backend, so-called back UI on the light and some front-end stuff. Vola Cloud Service makes the Light Tauri app lighter because of the name, light version. The app, for example, knocks on the service door and asks just to run the H app for me. And I will show some code in the VS Code to see what's going on the source code. Here's the library. Holochain bundle RS that I was talking about, that here is the all the implementation of the rich version. We have the configuration here in this file, but on the Holochain service, which is the light version, use this code, it's much smaller than the bundle one, as you can see. Here, we delegate everything to the Vola Cloud services. Yeah. Oh, you can't see my screen?
It's not shared anymore. There was a network interruption.
Oh, let me check it. What about now?
No, maybe the bandwidth is not sufficient. Maybe you switch off the camera and try to share the screen. Now something is coming up.
Okay.
Yeah, now we can see your screen.
Okay, you have to, yeah. Okay, it's a VS Code holochain service.rs. Okay, everything good? Okay. I was talking about the holochain service ROS file that is much less than the holochain bundle ROS file, because as I was explaining, the rich version has all of the conductor stuff, all of the holochain stuff in it in this file. But on the light service, to the Volla Cloud service, we have much smaller code here because all of the other stuff is on Volla Cloud services. So on the config RS, we have the app ID and the DNA, the binary at compile time. We have it here. We say to the conductor that we need this binary. And after that, on the UI, the conductor connects to the UI and does a first handshake and loads the app. And going to the presentation. Oh, sorry. Okay. And here it's a diagram how the application starts up from the beginning. Okay. When user opens the app, Tauri starts and loads all the native plugins that we talked about. We have some plugins. We have plugins because we need to create with the holochain and it's based on us and Tauri to handshake and community ROS file.
So, yeah, hopefully he can reconnect soon. So, yeah, hopefully he can reconnect soon. So, I am not sure whether we have also already some... hello. I think you have been interrupted after you have shown the flow chart, the last flow chart. Then we missed your...
Oh, too pity. Can you hear me now?
Yes, we can hear you. You are back. So the last thing we heard was the flow chart,
Okay,
the last flow chart. Anyway, we will publish all the presentations of the Volla Community Days soon on our download page of our website. Looks like Mr. Esmailpour is resharing his screen, but currently we can only see a black screen. Do we have...
yes,
I don't... Yeah? Okay. Go ahead. Do you hear me? Can you hear me? Is holochain also part of this session? Holochain announced to answer questions concerning their core technology. So Mr. Harris Brown told us, the CTO of Holochain Foundation, that he will join and answer questions. Did they reply, Mrs. Wiedenhoff?
No, they actually didn't. I'm sorry. I'm very sorry. I was expecting them as well, but I don't have a message yet.
Okay.
Have an information now.
Okay, I'm back. Can you hear me?
Okay, now your screen is back. Yeah, now your screen is back and we can hear you.
All right,
Go ahead.
Sorry, my network was breaking up. I changed my network. Okay, we were here on this slide, the one startup diagram to remember. when user open the apps, the Tauri starts, and the Tauri needs some plugins to communicate to the holochain ROS files. For that, we wrote some plugins, and in step number 3, the plugins, the native plugins, loads, and after that, the connection between Tauri and conductor will establish, and the UI connects through the WebSocket that we define. And after that, there is a call zone, which is about handshaking, send a ping parameter, and when the ping is pong after that to the response, the app is ready and we are good to go. And the app is up and running and we can send data and receive the data. After the app gets ready, as I said at the beginning, there are some type of data in the zone. We have 2 types, integrity and the coordinator. Integrity is defining the type of variable that we want to use for developing the zone. And the coordinator is the function that we use those variables to write down some APIs. Like when you developing a backend for your website, you use REST API. We see the call zones here as APIs. We can communicate with the conductor with these APIs. So here, for example, we want to load contacts. We wrote a zone API with integrity code. And send messages, join conversation. We use this zone in the conductor. I show you some source code. I don't know, have you seen those or not? Yeah, I talked about the holochain service runtime bundle and config RS. And this is my presentation because my network, I couldn't be so integrated on my presentation. I'm sorry, because my network was breaking up.
Thank you very much.
Thank you.
Okay, so are there any questions to him from this room? Or are there any questions from the YouTube chat?
No, there are no questions.
Okay, so you find all these open source from for Volla messages and Volla cloud services also on github.com/hello Volla. So originally it was at the Holochain repository, then we moved this repository to our site. And everyone is invited from the community to review the code, to contribute to it and refine this app. There's a lot of things to do. I think next month we will have the first stable release with basic functions, text messaging, sharing files and photos. And this month I'm confident that we have a pre-release in the nightly build repository of our F-Droid, so you can test audio video conferencing. And one of our team has already started to implement the moderation features. This is a big epic, but essential if you use the Volla messages as an open channel to communicate with many peoples that you don't know. Because with Volla messages, you can share just a code to invite people to a channel, and then you have also the alternative way is to have private rooms with trusted people you have invited. Yeah, and we are currently also implementing this. Mr. Esmailpur is working on the data migration. This is nothing that the user will see, but it's very essential because if we have new releases with of the holochain core technology, the DNA of a group, or the DNA is changing, and we need to migrate the data so you can continue communicating with existing groups. This is also a smart way to remove data permanently that have been marked as removed in the chat. Okay, there's one question. Very good.
Thank you for a very interesting presentation. It's technical for a person like me, but my question is, I know some guys, they have developed a very nice social and they're not familiar with this framework, so they have been asking me.
Sorry,
like,
your voice is feedbacking.
These guys, they are unfamiliar with the holochain framework, but they will typically ask me how many resources would it take them to transfer this app, which is open sourced, to transfer it to the Volla cloud ecosystem.
Mr. Ismail, did you understand the question? Or
If you please repeat it again, because it was noisy. Sorry.
Yeah, sure, it was echoed also, but I know some guys, they have developed a very nice social media app. It is open sourced, but this particular framework is, of course, unknown to them. They are very much interested in migrating their app to the Volla cloud. So they were asking how much resources they typically would use to transfer their app to this new framework. Is that possible to answer?
Yes, of course. You know, for transferring the technology to the Volla cloud services, there is no need for some big stuff. You have to be familiar with the the concept of the holochain and how the zones functions are working together, and conductor work with the zone and DNAs, and the how you can develop the ROS code in the backend and the core service. You need have the stack of Rust and the communication protocols, and you'll be good to go for that. You know, there's no big resources, I think. Yeah.
So if it's a peer-to-peer application, I think the transfer efforts are much less than if you have a centralized application, because the way to connect to other peoples is different. If you have to an app that uses centralized account management of all the people that are using that service. In a peer-to-peer application, you are usually exchanging keys to be connected, and so they can reapply that approach to the holochain technology, I think, right? Okay, so any other questions, maybe or general questions, how the Volla Messages app works? So currently, as I said, there are two options to start communicating with other people. The first option is to create a contact. For this, you send a contact code to your friend, and your friend replies with an invitation code. So first you send your contact code, And then with the contact code, your friend creates a contact in the Volla Messages app, and once he created the contact, he sends back a confirmation code. And then you take the confirmation code and take it as an invitation, and then you are connected, and both people, both sides, your friend and you, see a new contact and a new one-and-one chat. Later, you can use that contact or that chat to add further verified contacts of people you know. So it's very secure, you exchange keys. And for this open group, you just create a group, and then you have a key, and then you send around the key. Maybe you publish it somewhere, and people that have the key can just simply join. It's like a Telegram invitation. So you have these two different features or levels of privacy, security, and of authenticated people. And I think in one of the new version, maybe Mr. Esmailpur, you can confirm, we have also a QR code that is now working.
Yes.
So we don't use the Google Play API. We have some other library that we use to scan the QR code. So if you meet a friend, then it's quite easy to get connected in the Volla Messages app.
Maybe one question. All right. Thanks very much for the presentation so far. Dr. Woods already tell the thing. So from you have more people invited with a code or with a QR code. It's possible over different countries. How many people can maximum attend if it is not peer-to-peer?
Could you please repeat the question?
Yeah, I am not sure that for that question it would be great to have Holochain here. Mr. Esmailpur, did you understand the question?
No, please repeat again.
Yeah, it was a question how many people can join a group with that peer-to-peer concept. Correct?
Even without peer-to-peer, but with invitation code by QR.
Yeah, it would. So even with the invitation code, it would also be a peer-to-peer. So it would be a totally private network. It's just a different concept whether you would like to communicate with authentified people. If you have a very private group and you would really like to know that the person you communicate with is exactly the person you want to communicate with, and you have verified contacts with that key exchange. And if you have an open group, it's still peer-to-peer. Do we have any knowledge about the number of people staying in a group?
As far as I know, there is no limitation to join the group because you are assumed and known as a peer, and you can, join as much as peer in a group that you want. There is no limitation, I think. But the Holochain team, Mr. Brown, can explain it more in detail, technically.
Exactly, and it's even a benefit if you have a large group, because each peers are synchronizing each other. So if you have maybe a kind of Volla Messages channel instead of a Telegram channel, so if someone is offline and maybe the one who have published the information is offline, and you join this channel after the author is offline, then you get despite of the author is offline, you get the message of him because it's synchronized by any other peer in the group, and the more peers are in the group, then it's I think a benefit. Do we have now Mr. Harris Brown? No, he is in the chat. No, but Mr. Haug has a question.
So this is a practical question. Can you hear me?
Yeah.
Okay. So. Okay. Good. So I work with sales, and when I talk about Volla Cloud, it universally arouses a lot of interest. So the question is very often how do we get our apps onto the Volla Cloud? So the practical question is. What resources can Volla offer in the sense are there persons that these app developers can contact at Volla to get like a flying kind of start to migrate their apps?
Yeah, for sure. First of all, if someone creates his own app for Volla Messages, for Volla Cloud Service, then this app can just simply installed on Volla OS, or because while maybe stock Android will be protected and only the installation of apps of Google Play Store are allowed. So, but for sure it's also possible if you want to have it in for anyone, then you can publish your app in the Volla in the Google Cloud, in the Google Play Store. We plan, by the way, to publish the Volla Messages standalone app in the Google Play Store. And what we think about and already discussed is whether we have in the future a kind of app store or app repository that is visible in Volla OS. Currently, the Volla Cloud Service has two tabs. One tab is to switch on and off the service, so the user has full control whether he wants to use the service or not. Another tab is about a list of registered apps. Currently, you have maybe the Volla Messages and the Volla Recovery app. And maybe we can think about a third tab for a repository to further apps you may want to install. Or we have an additional app store, or maybe why not another repository in F-Droid, so it would be integrated well in an app store that the people already know. So that would be also be very nice to have maybe a public another public repository that we include in our F-Droid, so people can easily offer their app, and it would be advertised and shown up on the screen of F-Droid.
Yeah, and I also have to add something. If someone wants to develop an application that is connected with Volla Cloud Services, they can add the dependency that we have open source to the project, and the project, when it gets built, it can communicate to the Volla Cloud Services, and we have that application on the tab called installed application for Volla Cloud Services, and we can remove from there or uninstall it or see the application connected to the Volla Cloud Services. They can use the dependency for that.
So it's easy to everything is open source, so someone can start to develop the Volla Cloud app, and it can be installed easily by an APK package, and so you can download it. If you are a corporation, you can push it even via MDM, and so that's you can just start right away. And also you can ask questions. GitHub has this issue board, and you can ask a question, or you can contact with the You can contact the contributors to the project. This is also transparent at GitHub. Yeah, I also would like to see a B2B application that make use of the Volla Cloud as a corporation. You can really have, you will have your own network. Our cloud approach is not that the data is split up and stored anywhere. It is stored with the peers you decided to be connected with. So a corporation or organization can really create their own network, because the DHD table that is created for an app is only distributed for the peers you have decided to be connected with. Okay. Any further questions or inspirations or requirements you would like to see? Also, Mr. Gaberi is still sitting here. So maybe for some developers it's more convenient to develop in Kotlin. So it's the way they used to develop Android apps. But if you are a Mac app developer or a Windows developer, Linux developer, maybe Tauri is a good choice. We hope that we can in July also, or maybe it takes a little bit longer, but summer at least, that we can also offer this app on iOS. iOS is a closed system, so users can't install any app without the App Store, but our plan is to bring in the Volla Messages app also to the App Store. This is what Mr. Esmailipur has explained, that you can choose different targets if you use Tauri as the cross-platform application framework. Yeah. And if you have another operating system, maybe there's someone listening and is interested to bring in Volla Messages to Sailfish. But I'm afraid then we need another Tauri plugin. But who knows? I know that there was a request for a Tauri plugin for a build target for Ubuntu Touch. But I think it wasn't picked up by the Tauri team. Maybe someone can work on it, but we have some synergies. Yesterday, Mr. Hamamjian presented desktop apps, and we think that with this improvement or extension of Ubuntu Touch, we can also bring the Volla Messages app to Ubuntu Touch, so that also these people that have a Volla device with Ubuntu Touch can benefit from it. Yeah, anything else? And currently, it's really challenging. We are working on connecting the Volla Cloud service with the Volla Meshnet, but we have two proof of concepts. One is that the Volla Cloud will use the Reticulum as a protocol. The other one is that Volla Messages is currently using IRO as a protocol, makes use of the MDNS capabilities of IRO that can be offered by the VPN that will be available for the Volla Meshnet. Okay. Anything further questions to Mr. Esmailipur or to Mr. Gaberi? If not, maybe Mr. Esmailipur, maybe you have a last comment and statement from your side.
Thank you very much for having me in this Volacom today. I was appreciated for that. Thank you, everyone, and have a nice day.
Okay, so I'm very happy that all the contributors from we have developers in very different parts of the world, in the west and the south and the north, and also sometimes Holochain is in the east, in the west. and we have a lot of in the East, so everywhere. And this is very amazing that we have these talented developers contributing to the vision of Volla. Yeah, so we are come to the closing of the Volla Community Days. Very on time at 3 p.m. as we planned. But maybe we have now time for some final questions, and you are also welcome to ask your very general questions about Volla, whatever, or Remscheid.
Okay, natürlich.
Yeah, it's just a general question. If one is buying the phone and unboxing it and stuff like that, check. I take the phone, put it on. Is micro G already installed?
Yeah.
Because that also is contrary. On one side I read yes, and the other side I read no. You have to create it yourself, and you have to watch it. That the configuration is very good. So is it installed or not?
Yeah, so thank you very much. I think to have a precise question, I say it's part of the operating system, but it's not activated. So it's part of the operating system because if this micro G has privileged permissions, then it works properly. If people decide to use micro G because they need to use an app that requires Google Play services, and in the setup assistant of Volla OS, you come to a page where you can decide to enable or disable it. And if you keep it disabled, this is the default setting, then you can enable it later at any time. And if you enable it, you can choose in the system settings which services of Google you need to use necessarily. Maybe you only need to use maybe Cloud Push, or maybe some device registration. You can, even if you want, you can also log in with your Google account and use Google Apps. As everything what we are doing is an offering to customers. It's about freedom of choice. And if people want or must use it, then they can do it. You can use our devices as a regular Android device with no compromise. Only the last last gap is the Google integrity, Google Play integrity, but we have a solution for it. So you can use it as another Android device. And there's also in real life, you have sometimes a problem. You don't want to use some apps that you don't really trust, but you must use it because it's part of your job, or because you need, or your partner say you need to use whatever, maybe some communication app that you don't trust, like WhatsApp or something, or some other app that requires Google Play services, like your banking app. Then you could use as a compromise the the Volla security mode. In the Volla security mode, you can list some apps that are totally disabled, as they wouldn't be installed at all on your operation system if you activate the security mode. And you can combine this deactivation and activation with also activating and deactivating micro G. So once you need for a small moment or situation such an app, then you deactivate security mode, the app pops up, and you can combine it with the activation of micro G, then you use it, then you activate again afterwards the security mode again, and the app disappears and micro G is not activated anymore. I think this is the best compromise. I remember that the owner of our head office in Remscheid decided in the past to use a door that only can be opened by an app that requires Google Play services. So Google knows when we enter the door. But anyway, so what should you do? So for this compromise, I put this app on the list of Google, of the Volla security mode, and that was, I think, the best compromise. Okay, are there any further general questions, maybe from YouTube or somewhere else? So if not, then I think it was a very exciting 2 days, and for me it's very motivating to speak in person to the people, because what really matters is outside the digital world. This is my philosophy, my way to look at it, and I want to motivate and inspire people to spend time and attention to everything outside the digital world about our human relationships, and I want to also promote this. And so I'm very happy to see all the people that joined online, the international team, and the people at YouTube. I think YouTube has recorded the live broadcast, and you can watch some pieces afterwards. And our marketing manager, Mrs. Wiedenhoff, will also then, after post-process the video and enter some chapter marks, so it's easier for you to see the right parts that you are interested in. Thank you again also for Mitteldeutschland TV to be here and broadcast this event. And maybe we see us next year, and also in between in the different tools at GitHub or one-to-one meetings, and also your ideas. You can expect some more announcement this year. We are already preparing some other smart hardware products and devices, and also some more software. Thank you very much to all of you. Have a good journey and trip back, and have a nice spring weekend and Sunday. Thank you very much. See you.